Now that we've had the overview, let's take a deeper dive into each of the two neural networks used for the YouTube video recommendation system, starting with the candidate generation network. Just as we did with our design lab and neural network lab, hybrid models require intelligently assembling many other machine learning models into a pipeline. These use multiple data sets and model types to help give the best recommendations. The first step for candidate generation is to get the item embeddings, for instance from a trained WALS model. We then find the last 10 videos watched by the user and use the embeddings to get their vectors within embedding space. Next, we average the embeddings of those 10 videos, so we will have a resultant single embedding that is the average along each embedding dimension. This becomes the watch vector, which will be one of the features to our deep neural network. We will do the same thing with past search queries. Collaborative filtering for next search term is a collaborative filtering model that is similar to the user history-based collaborative filtering we talked about earlier. Essentially, this is like doing a word-to-vec on pairs of search terms. We will find an average search embedding, and this will become our search vector, another input feature to our deep neural network. We also should add any knowledge we have about the user. Location is important, so users can see localized videos, and also because of language. Gender may be important because perhaps there are differences in preference based on that. All of these are features added as inputs to our deep neural network. We also should add example age, because we don't want to overemphasize older videos. Why do we care about this? Well, older videos have more likes and more user interactions in general. You want the model to learn to account for the fact that older videos are more likely to have been watched or searched for. Hence, the need to add example age as an input. Remember, this is example age, not user age. These are all a subset of the many features that feed into our candidate generation neural network. Next, we want to train a DNN classifier. Now, why would we want this model type? When you think of a DNN classifier's output, it becomes pretty obvious. The output will be a probability that this video will be watched. So, taking the top n of these videos is probably what we want. These come out of a softmax for training. But there are two other considerations. There's also a benefit to finding the closest users and generating those candidates as well. This is the way that viral videos are created, videos that a lot of people like us are watching. Therefore, we can treat the last but one layer, or the layer right before the softmax, as a user embedding. This is also a benefit to finding videos related, content-wise, to the video you are currently watching. Therefore, we can use the output of the DNN classifier as video vectors. This combined with the last ReLU layer as the user embeddings generates candidates during serving. So nearest neighbors consist of neighboring users and neighboring videos. We now know the magic behind YouTube's candidate generation neural network. So let's see what we've learned. During training of the candidate generation network, what output layer should we be using and what should we be predicting with it? The correct answer is E. We are trying to generate candidate videos to send on to the ranking network, half of our hybrid recommendation system. Therefore, by using a softmax, we can get probabilities of which video will be watched, and we can then take the highest ones and send those as our candidate videos to the ranking network.